let's talk about rotations. A rotation turns the plane either clockwise or counterclockwise around a fixed center. To describe a rotation, we need three things: the angle, the direction, and the center of rotation. That center is extremely important. Without it, we don't know how the figure is turning. Let's start with this triangle, and we want to rotate this 90 degrees clockwise around this indicated point that I have. Since this is my center of rotation, that point does not actually move. I went ahead and drew an X and Y axis where the origin is through my axis of rotation. Doesn't really matter where the origin is, but this will make the problem a little bit easier if we put it right at my center of rotation. So let's start with this point here. If we want to rotate it 90 degrees clockwise, we're spinning this way. So it's going to get moved up here. In particular, I can see that I moved down 3 and over 2. So in this one, I'm going to want to move over 2 and up 3 to get to this point here. So when I spin it, I'm actually going to move over 3 and up 2, opposite of what it was before, to this point here. We'll do something similar to this one. It's going to end up over here. It's actually over 3 and down 3, so now I'm going to go over 3 and down 3 again, to this point here. Then we can connect the dots of this triangle, and we have our new rotated triangle. This is a good moment to pause and remember. A rotation preserves distance, but it changes the orientation and the position. Next, let's consider this triangle here, and the indicated point is going to be my center of rotation. This time, I want to go 90 degrees counterclockwise around this particular point. So this time our axis, our center of rotation, is not the same thing as a point on our triangle. I once again went ahead and redrew some x-axis and y-axis. And just like before, it doesn't really matter where they go. But it is more helpful and a little bit easier if we put the origin at our center of rotation. So this first point here, we go over 2, we go right 2, and up 0. As we move counterclockwise this way, we're going to need to go up 2 and over 0 to this point here. For this one, I go over 2 and down 3. So now I need to go over 3 and up 2. And then this final point, it goes over 4 and down 3. So now I need to go over 3 and up 4. And then I can connect the dots for my new rotated triangle. Not the best line there on the right, but that's okay. This is a great place to help students understand what a rotation really means, instead of rushing to formulas. As future teachers, this matters a lot. Students often confuse the center of rotation, the direction of rotation, and the angle of rotation. One helpful strategy is to draw a segment from the center to a point on the figure. Then show that segment turning through the given angle while keeping the same length. That visual makes the motion much more understandable. You might tell students a translation slides, a rotation turns, and a reflection flips. That quick comparison helps organize the ideas. Even if rotations feel a little less comfortable at first, that is okay. They often take some time. Visual reasoning is still real mathematics, and you're building it carefully. In the next video, we will look at reflections.